Now, it's sort of like. It's just the original brand.
Where did we, what is it?
Bingo. Yeah, go down. Yeah, keep it down.
We're working on this as a warm up. What was it?
Something they're taking photos for me.
And put it where?
In the photos downstairs.
Oh, interesting. You're taking photos downstairs? How did you find it? How did you find
That's
it?
just my.
Okay, that's helpful then. Did you get it?
Let's not.
Okay, 2 seconds. That's it. Okay, you got it?
So this is like. Zero. Minus. Minus seven. So like. I don't mean. What? Yeah, this is X, Y. Yeah, but one piece. One piece. That's fine. Thank you. Very much.
We about done? They must be doing the same warm up. It's really exciting. Okay, so let's go ahead and do this one. Can you please show me what the parent function looks like? Show me what the parent function looks like. The gesture would be this.
Exactly.
Or is it this? It's this one. This would be cube root, right? This would be cube root of x. So this is x cubed. So we're going to start with that. And I think ultimately only 3 points are going to fit. So I'm just going to have these 3. And then I'm going to have this dashed. Is this how you started with these 3 points? Okay. And then from here, we have some stretches and we have some translations or shifts. So what comes first? The 3, that's stretch. Can you please show me in gestures what the 3 is going to do? We know it is a vertical stretch, gentlemen. The vertical stretch because that 3 is on the outside of the function. So it's going to be vertical stretch by a factor of 3. So in other words, this that used to be 0, 1 is now going to be 0, 3. Are we going to put a point there though? No, because it still has to move 1 to the right and then down 2. Were you able to handle all those 3 things at once? Okay, so I'm just going to do one at a time. I started with this upper right one. Right? So this one I'm not reflecting, I'm stretching it. So it goes here, and then I need to go to the right 1 and down 2. Is that correct? Did I get that right? I'll do this in a different color. Man, that's pretty extreme. I may have to talk to them. I need to. Can I get a color here? Here we go. I'll do this in green. Okay, 0, 0. When we stretch that, it's gonna stay at 0, 0, and then go right. That stretch 0, 0 stays right there, and then it goes 1 to the right and 2 down. So right there, I believe. And then the other one, stretch it to 3, -3, 1 right, and then 2 down. Do you have these 3 points on yours? Exactly, that's what I'm looking for, so, and then from there, just make sure to get that curve going, something like that. That's all. Uh-huh. Yeah. So let's follow this point. If the coordinates are -1, -1. First thing that happens is we stretch it by a factor of 3. So this stretches down to -3. So
it's like
temporarily,
basically multiplying -1 by 40.
that's exactly what we're doing, yes.
Okay.
And then from there, we continue by going 1 to the right and 2 down, 1, 2. That's how we got right there. I hope that's comfortable. Like once you understand how to manipulate the points, it really shouldn't be crazy, like mind-blowing stuff for you. And ultimately, it should look something like the original graph that you started with. Yeah? What's the domain of this function? You just check in with your neighbor. What's the domain? And it's going to be the 3 of you today.
You turn your table around. Yeah, sure. You don't want to turn your table around. I'm good.
Doesn't turn the table around. So domain, I'd like to hear about the domain from Ben is not here. Sorry, Ben, you're gonna have to wait till next time. Joseph, what's the domain here? How did you know this?
Well, that's just how it looks like.
Okay. Just looks like one of those negative infinity to infinity guys.
Oh, like it continues there, like on both like places. It continues and it doesn't have like a certain like stop point. So
Okay.
on the right, it continues going up. So then it's gonna infinitely go over there, and the other one's negative because it's just gonna keep on going over to the left.
Perfect. Perfect. Right, when we're thinking domain, we think wall to wall, so it doesn't stop going to the left, doesn't stop going to the right. Domain is all real numbers. There is no wall, exactly. And remember, domain is just all values that x can be. I hope it makes sense that there isn't a number that it can't be. You can plug in any number into this function. Okay, let's do today's session. It should be pretty quick. You should have time to do some working class, but you never know. Let's see how it goes. To the packets.
Freaking back.
Okay, so there should be no talking now except for the guy in pink in front of the glass. Very good looking with glasses. So domain just means the collection of values or the collection of inputs. That are possible. For a function. Okay, so for A, do we need to graph this to know the domain? Or can you just see that, well, is there any number that you can't plug into these values of x? If you have a calculator, anything is fine. So domain here is from negative infinity to positive infinity. Do you want to graph it to verify that? Me neither. But could you imagine plugging in -1,000,000 and getting just a crazy number and then plugging in like 1,000,000,000 and you get a number. It's not like you can't plug it in. So any number could be plugged in, negative infinity to infinity. Done. B, there's something we have to watch out for, isn't there? Would you please just check with your neighbor? What do you have to watch out for in B when you're finding values of x? Okay, so I'm going to ask someone what we have to watch out for in this case. Could be specifically or generally. Luke, what do you think? What do we have to watch out for in B? Anything? Yeah, so we have division here. So then what do we have to watch out for since we have division? The bottom, what do we have to watch out for? Bottom. Luke, you have an idea? Exactly. Can't be 0. So did you figure out what would make that denominator 0, Luke, by any chance? Have you done that work yet? Okay, so the work we're going to do is that we're going to say x squared minus 2x minus 3 equals 0. And then whatever we get, we say the domain is anything but that. Trying to solve that quickly. Can you show me the numbers that are excluded from the domain? I'd appreciate it once you have them. And take a look around once you have it and verify with other people. Make sure you got the same thing they did. Let me see what you got. Yeah, everyone who's holding it up, and it looks like this side of the room has it. What's going on with the left side there? Okay. That's a waiting. Okay, so I'm saying 3's and negative 1's, is that right? So very often, and this is just x minus 3, x plus 1, I believe. And so you get x equals 3 and negative 1. You could also just factor here and say, from here, the domain. Have we talked about domain like this? I forgot if we talked about it in this class. Okay, so domain, if I'm thinking about this on a number line, then it can't be negative 1, it can't be 3, but it could be anything else. So I could write this as in interval notation from negative infinity to negative 1, union negative 1 to 3, union 3 to infinity. You could do it like that, or you could just say x doesn't equal negative 1 or 3. And that's fine for me. Give you the crazy obnoxious one first. Yeah, because if I didn't, then you would never listen to that other part, right? Be like, I got it already, Mr. Lieberman. Okay, for C, in this case, what has to be true about the inside of a radical, a square root specifically? Has to be, well, does it have to be positive? It has to be non-negative. Is that the same thing as positive? Non-negative? Is that the same thing? It's almost the same thing because one number separates them. It could be 0. So we'll just say that 3x plus 12 has to be greater than or equal to 0. That's how we're going to get our domain here. So I don't want you to think, what numbers can I plug in? Just let algebra do the work. So we have 3x is greater than or equal to negative 4. Do I have to, actually negative 12. Do I have to reverse this inequality when I divide? Nope, I'm dividing by a positive number. X is greater than or equal to negative 4. So you can put it in that form, or you can put it in interval notation. Is that difficult? I don't think so. Negative 4 to infinity is fine. So this is a domain. This or this. You don't have to write both. And for D, in this case, could this be equal to 0 in the denominator? That thing which I circled? It's a denominator. So in this case, it's going to look the same, except it's 14 minus 2x is greater than 0, not equal to 0. Doesn't matter what's on the top. It does not matter. So we have negative 2x is greater than negative 14. So x is less than 7. That is our domain. And I'm just going to leave it algebraically instead of writing algebraic and interval. Yeah. All right, let's move on. Algebra of functions. I'm just going to say, you can do this. You can do all these two functions. Could add, subtract, multiply, and divide functions. What's it? Oh, you can do all these two functions. All these. Sorry about that. Really, the important thing for you to understand is what this means. We have two functions, f and g. A is just saying to take these two functions and add them together. So what is this right here? What's going on with that? How do you read that? Yeah, nice. This is the same thing as saying f of x plus g of x, or f plus g of x. So we're just saying that x is the variable. Thank you, Jack. So that just means when we do this, I'm just going to take the first function, 2x plus 1, and add it to x squared plus x minus 2. Am I done? I'm done. I just haven't simplified, so I guess I'm not done. So, standard form, x squared plus 3x minus 1. It is asking for the domain of each function. Domain? Should be no surprise that it is all real numbers. How do I know that? It's a parabola. Nice. Or just thinking about it, there's no number that can't be plugged in, unlike divisions or radicals. You see what we're going to do for B?
Get y as addition.
You don't get what? Oh, just because of this plus sign. That's just what it means that we're adding function f plus a function g. Yeah, so here's f of x and here's g of x. So this is my f of x and this is my g of x. So this is just saying, and this is part of just understanding the language. This is all this is saying, and it looks complicated that we're adding the two functions together. That's what I'm doing. Like this one is saying we're going to take the functions and subtract one from the other. I'll give you a moment to do that. Please be careful with subtraction. Interested, did that answer your question? Sure. Thanks for asking. Check the neighbor, make sure they got the same thing you did. I will be asking for the answer from one person on how they got it. Are you ready? Okay, Jack, can you tell us what you did here, please?
Yeah, I think 2x plus 1 and then minus x squared plus 2 x squared plus x.
Are the parentheses important? Yeah, okay, keep on going. And you got?
I got minus x squared so that, then I changed it to x squared minus x.
Okay, are we okay up to here? So can we change this? Because it's a little bit uncomfortable, don't you think, to start with that negative in the exponent? I agree with you. Can we change it? Would it be appropriate to distribute a negative or to multiply by -1? If we had that this is equal to 0, then I'd be completely on board. But this is not an equation. They asked us to just subtract one function from the other, and the result ended up to be negative, and that's fine. Just as the same as if I were to say, what's 3 minus 5? Then the answer is just -2. You can't just change that to a 2 because you have something against negative. So it's same thing. So don't be afraid of starting with that negative leading coefficient. But thank you for even considering it. I appreciate that. Are we good with that? Do you have the same thing? Domain? All real numbers like that. I wonder what's happening with the two functions in C. Yeah, you're not just jamming them together. Go ahead and multiply them together. I'll be calling one person to give us a final answer. One lucky person, I should say. Finish? Did you check? Okay. I'd like to hear from the one and only Tess. What'd you do here?
I was getting trust in my phone.
Well, you took these two functions and, like we said, multiplied. And what property did you use? Thank you very much. So what's your final answer? Do we agree with Tess? Nicely done. Thank you, Tess. For domain, all real numbers. And if you wanted to say all real numbers, or if you want to say X is an element of real numbers, that's fine too, something like that.
For A, you just said all of them.
Yeah, any one of them. So, of course, for D, you just take these two functions and divide them. I'm so sorry that this lesson is just kind of, there's no excitement here. So I didn't call on someone for that, but I hope that it makes sense that we're kind of done with the problem. Except we have to figure out the domain. When you just check with your neighbor what the domain is. Domain, I need to hear from James. Help us out with this one. Get this one? How far did you get? Oh, so you didn't do anything?
Well. Not quite sure.
Okay. Okay, well, let's talk about this. A, B, and C, the domain was all real numbers because we could plug anything into those functions. Can we do the same thing here, or is there something we have to watch out for?
Zero.
Zeros of what? The top or the bottom of this? Exactly. So we have to watch out for the bottom of this fraction. What do you think would be a good idea for me to do with that denominator? Let's factor it. I think that's a good idea. Yeah. So 2x plus 1. Factoring this, I like to start with empty parentheses. Does anyone else do that? I just like to have like a gameplay here. And then I say, I know that it's going to be x and x. Now I'm just looking for two numbers that multiply to be -2, add to 1. I think those that exist. Right, James? So the numbers are. So multiply to be -2 and add to 1. So
Oh, no, -1.
like this. Are we good? Is this enough to help us get the domain? Would you please show me the exclusions for the domain, please? Too many pleases. Nice. Yeah, it can't be 1. It can't be -2. Yeah, so x, and that's what we're going to write. X can't be 1. It can't be -2. James, thank you for your help. Okay, a few more. I really like example 4. We're finishing off with a bang here, but 3. We're just going to take these two radicals and add them together. Okay, done with that part. Or could we add these? No, if they don't have common inside the radical, you can't put them together. So we are done. Please don't try to do that. At the domain, though, of this. Is it all real numbers? Go ahead and discuss, because we're just trying to figure out what numbers can we put into this function. Is it all real numbers? Did you get it? Okay. Is it all real numbers? What's the smallest number that could go in here? 0? Could 0 be put in here? If you try to put a 1 into this function, the second part will be a problem, won't it? So the smallest number that can be plugged in is 2, is that right? Could you plug in a 2 to this function? And this function, when I say this function, I mean this as a whole. Could you plug in a 2? Yeah, it's not a problem. How about a 1.9? No, we don't want any negatives in the radicals. So the domain is 2 to infinity. And the formalized way to do this is we look at each part. Does it make sense that what I just did is the domain for square root of x plus 3? And then I'm also going to do x minus 2, which means it's going to go from here. So this one is x minus 2. Does that make sense? So we just want all the numbers that satisfy both, which is why I look here. That satisfies both. So the number lines may help, but I think you're able to do this intuitively. Okay, lastly, now this is a different kind of problem than what we've been doing. And I'm going to take us back to what Jack mentioned in the beginning. I'm going to rewrite this as f of -4 plus g of -4. because I know what f is, and I know what g is. So I just kind of break it up into two. Take a look and see if you can figure that out. What is this? If you have an answer, go ahead and hold it up. The people who have ventured to give us their answer are correct. And I'm just going to go through it. F of -4 just means what's the output for function f when the input is -4, and how do we get that? The graph. Here is f of x. That's the blue one. But when you plug it in -4, you get 5. The first one is 5. Yeah, and then g of -4 just means the input is -4, but you're plugging this into the g function, which I think is the red one. And when you plug in the 4, the output is 0. Then we're looking for the y value there. And if you practice your addition at home, you know that 5 plus 0 is 5. Yeah. I'll give you a minute to finish the rest. Today is all about just reading functions. You please show me what you got for B. Yeah, -1. Just make sure you started with the correct one. G of 0 minus f of 0. We can see that g of 0 is 1 and f of 0 is 2. For C, can you show me what you got? I'm saying 4. And for D, no solution? Undefined? Yeah, undefined. That's no fun. Okay, that's all I got for you folks. You have time for your assignment.